So finishing up this section on ionic compounds. Some ionic compounds, as they crystallize from an aqueous solution, will incorporate a particular number of water molecules into their crystalline structure. And we call these hydrates because they have water in them. They are not just wet solids, though. They actually have a specific number of water molecules for every formula unit. So Epsom salt is something you may have heard of. You soak your feet in that. Epsom salt is magnesium sulfate. For every magnesium sulfate formula unit, there are 7 water molecules in the crystalline structure. And so we need a special way to name these. We name the ionic part the same way that we've been studying. That would be magnesium sulfate. And then we use a prefix, a numerical prefix, to tell us how many water molecules, and then the word hydrate for the water. So this is magnesium sulfate heptahydrate. Cobalt 2 chloride also does this. It makes a hexahydrate. So that's cobalt 2 chloride hexahydrate. It's important to understand that this dot is not a multiplication sign. You cannot multiply chemicals. When you find a molar mass of this substance, you do not multiply the molar masses of each part. It just means they are together as a hydrate. Hydrates are going to have some different properties than the anhydrous salt. So anhydrous means without water. So here's cobalt 2 chloride. This anhydrous, it doesn't have any water associated with it. When it crystallizes with water, 6 water molecules for every formula unit, we have the hydrate, and it's got a completely different color. Any questions? So we need to know the prefixes. These are, for the most part, the same prefixes we're going to use when we name molecular compounds. The only different one here is hemi. Hemi means half. The rest of these, mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. You need to know those, okay? Most of them are related to things we know in everyday life, like a pentagon has 5 sides, a triangle has 3 sides, etc. So let's practice naming these hydrates. We name the ionic portion first, and then the hydrate part. So how would we name CaSO4? Calcium. And does calcium need a Roman numeral? No, it's in group 2. We know what the charge is. SO4 is what? Sulfate. So calcium sulfate, and then how do we do 1/2 H2O? Hemihydrate. Does anybody wonder how you can have half of a water molecule? Yes. Yeah. That's an excellent thing to wonder. You can't. So why do we write it like this? We want to always have the normal ionic formula for the ionic compound. In this case, we have 1 water molecule for every 2 formula units. Okay? And so the way they've decided to write that, instead of doubling this, we're going to cut the water in half. There aren't any half water molecules, but there are 2 of these for every 1 of those. This is just how they've decided to do it. Does that make sense? How about this one? What's the name of this one? Calcium. It's a little boring that it's the same metal ion in both of these. And then Cl is just chloride. The prefix for 2 is di, so dihydrate. And some ionic compounds can form more than 1 hydrate. They might form 1 hydrate with 2 water molecules, another with 5. Just not really, we can't really predict that. And then we should be able to write formulas. So barium hydroxide octahydrate. Barium hydroxide, we need to think about the ions with their charges. So we've got barium. What's the charge on a barium ion? 2+. And hydroxide is one you should memorize, OH-. So we look at the charges on those, and we see that we need 2 hydroxides to balance the charge on one barium ion. So that's barium hydroxide. And then octahydrate, we just put a dot there, and octa means 8, and hydrate means H2O. Okay? Any questions?